Good afternoon and welcome back to the workbench. Let's try and do an actual repair for once. Or I should say, really, welcome to the floor. Here is a rather large speaker. Funny story with this one. I wanted a small portable speaker of fairly decent power and quality, and I saw this for sale second hand as not working. No details as to what that meant. I took a quick look at the picture, thought it looked alright. Bid on it, got it for like $20 or something. When I went to pick it up, I found out that it's rather large. It's a Behringer B300, I think, something 300. It weighs a ton, and it's 300 watts, and it's literally designed for like outdoor PA stuff for doing concerts and things. It's I was expecting something about a quarter or third of the size, like 50 watts, and significantly less big. Unfortunately, I bought this a few years ago and then I never really used it because it was just far too big for what I wanted, and you can see it, stands as high as my knee here, in fact higher. Anyway, I don't know, they said not working, but it does work. It just has a slight issue with it. It had two issues actually, in fact. I'll move the camera back to the workbench and we can talk about that, and then we'll try and figure out what's going on with this thing, which I've had lying around for like 5 years, and I finally kind of want to fix it up. Anyway, so I thought, well, I might as well take the thing. It's only $20, even if it is far too gigantic and heavy for what I actually want. But I took it home and I tested it out, and it does work. You do get sound out of it. You stick an audio signal in and it comes out, and it's pretty loud. But I did notice one problem, and that was the input jack here, or at least the unbalanced input jack. They just use a standard like stereo input thing, I think. This didn't have very good tension on the contacts, or something was going wrong with it. Dirty contacts, or not tensioned properly. The thing's worn out anyway, so I figured I could get in there and I could possibly get a screwdriver in the back and push the contacts in, I could clean them, and then I could put it all back together again. But I figured, I might as well just put an entire new one in there at that point, because I'm going to have to desolder the whole thing through a double-sided board, and why bother going through all that when you may not fix the problem? So I just bought a brand new jack for it and just put that in. So this is the old one. It might have been fixable. I don't know. I'd rather just put something brand new in. Anyway, that solved the problem of that input being loose. You could wiggle the jack around, it would make noise and popping and all that kind of thing. It wasn't very good. The solder connections are perfectly fine. It was actually the socket itself that's bad. Again, dual-sided board, through-hole, soldered in really well, no cracks or anything. That wasn't the problem. The jack itself is just worn, I think. Yeah, so I replaced that with a brand new one. That totally fixed that problem. But another problem remains with the amplifier, with the speaker, is that even without any input, there is a background low-level hum. Actually, a kind of a nasty sort of buzz in the output in the speaker, and I don't think should be there and does not sound very nice. And so I'm going to troubleshoot that and try and figure out what's going on. It's a pretty basic design, really. I'll just see if I can switch to the schematic here. Okay, here's the schematic here. It is a B300 ultra wave. They've got a bunch of different revisions. The schematic is almost identical. Hard to tell exactly what the difference is. Like here we got revision I, revision J, revision C for the input preamp, revision D, revision E. Anyway, I don't know why there's so many different versions, but we've got a preamp here. You can see we've got the inputs. It's got an XLR input for a balanced input, and then a loop through, pass through thing. We've also got this jack here, which is the one I just showed you. It's just normal stereo jack, and then we got this goes into this op amp here, 4580, and gets converted back to unbalanced, I guess, whatever. We got like a little optocoupler for feedback for a limiter, and you've got like a feedback and LED to show you when that's on and all this kind of stuff. Yeah, and then we got, you know, tone controls in here, bass, treble, some other stuff going on. Low pass, I guess, for the output for the subwoofer amplifier, and then high pass, I suppose, for the tweeter. And that's about it. So very simple sort of input preamp thing, because it's got two drivers in the chassis there. So a pretty simple thing. We've got a preamp section, which just does the basic kind of stuff you'd expect. And if you go back up here, where is it, to the main schematic, we've got a pretty simple thing. We've got a great big huge toroidal transformer which comes in on these 3 pins here. We've got a bridge rectifier made of 4 diodes. We've got some filter caps. We've got our main plus VCC and minus VCC which go out to the power amp, and then we've got the like plus minus 15 volts which go to the preamps, I believe, V plus. And then we have the main power amp section, which is basically a bunch of LM3886s all parallel together. We have 3 of them parallel together for the I believe for the woofer, which connects on this point, and then we've just got one, I think, for the tweeter, which connects there. And this here is, what is that? Some kind of feedback protection, maybe? Level, clipping indicator, maybe. I can't remember exactly. I think it might be a clipping indicator feedback thing, circuit there. Anyway, that's not the point. I'm getting sidetracked, completely sidetracked. That's not the issue. The issue is, like I said, there's a horrible buzzing noise that comes out of the speaker when I turn it on, even without any input. And I can think of 3 things right now that could be that. It could be we could have a bad power supply. One of these rectifier diodes could be a bit dodgy. Could be causing some issues with that. One or more of the filter caps could be bad. Could be open circuit, dried out, whatever, I don't know. High ESR causing ripple. I haven't actually measured the frequency of the noise, but it does sound kind of like 100 Hz, which would make sense for here, where we have 50 Hz mains. And then of course one of these regulators, 7815, 7915, one of those could be bad, feeding the preamp. The preamp could be getting bad power. The preamp itself could be faulty. One of these op amps might be bad. And the input section, maybe a shorted cap somewhere or some weird thing, I don't know. Anyway, or maybe the power amp could be faulty. I mean, we do have these chips all in parallel, and it's possible that one of them might be bad. And clearly, enough of them are working that the whole thing still produces audio, but we've got 3 in parallel here for the woofer. Maybe if one of those was faulty, we'd still have the other 2 working, the other one's making a noise, distorting a bit, I don't know. Anyway, it could be several things. So a bunch of things to check. As I said though, it's a pretty simple circuit. You only really have 3 sections. You've just got a power supply, a preamp to do tone control and splitting the different frequencies to the different driver circuits, and then you've got the main amps which have these chips, which again are pretty simple. 50 watts each, I think, per chip, so I think they sort of times that by 4 and get 300 watts somehow. Okay, so just looking at the back for a quick second, you can see there we go, claims to be 300 watts. I'd say that's pretty optimistic. That would be like at maximum power, where the thing would probably be starting to run into thermal limiting or something. So yeah, anyway, most audio systems are like this. The claimed wattage is usually peak instantaneous, best case fantasy land numbers, but still pretty loud though, I mean, to be honest. We got all the inputs here. We got the I love this integrated sound processor. It's literally just a couple of op amps and a couple of pots for you to change the bass and treble. Not really as impressive as the name and description would have you think, but that is the case with a lot of audio equipment. We do have XLR in and pass-through and everything. We got the standard jack input, which, as I said, I already replaced that with a brand new one. So that fixed that other problem, but yeah, we've got an issue with the sound. I'll see if I can plug it in and see if I can pick up the noise. I've got the thing plugged in, and I don't know if you can hear it, it's not super loud. It doesn't make any difference if I adjust the volume control at all. When I touch the input on the XLR, you can hear the standard 50 Hz hum. You'd expect to hear. I still don't know if this is actually a fault or not. I mean, I'd say it is, because I don't know of any other amplifier that makes a buzzing noise like this when it's just sitting there doing nothing. But I must admit, it's not particularly loud. But it's definitely different to like the hum pickup if I touch my finger to it. Yeah, so it's rather strange. But it's definitely noticeable when you switch it off. You can hear it go away. It's not that noticeable when it's on necessarily, but when you switch it off, definitely you can hear the silence. And I think, I don't think it's supposed to do that. I think it is faulty. Alright, so this thing is a little bit of a pain to troubleshoot, because all the plugs and stuff for the speakers and the transformer, cabling is kind of short, and anyway, I don't know, so I'm just doing some sort of basic offline checks at the moment to see what's going on, see if I can spot anything obvious. To get the board out, you have to undo the heat sinks, of course, from the back panel, and then you could access the things, and then you got to undo the bolts here that take the chips off. I don't want to undo everything just right yet. But anyway, I saw something that I thought might be something, but I'm pretty sure it's not something. But I thought I'd just talk about it. Anyway, so if I check the rectifier diodes here, so there's 6A2 diodes. We get 466 on that one. This is forward biased. We got 470, 469 on that one. 458 on that one, 463, they're all pretty similar, will make sense. And I thought I'd try them backwards to see if there's anything weird going on. They all measure like 1.8 volts across all of them, backwards, which I thought was kind of strange, but if I check a normal supply, you normally just get the charging filter caps and it just goes above the voltage. So I thought that was kind of odd. All the diodes leaky? Probably not. They do all have little 47 nanofarad polyester MKT capacitors in parallel with them. But I think what I'm actually measuring is like the 15 volt regulators, which are down here. Again, really hard to show because the way the camera is and the way the wires are and everything, but there's a 7815 and a 7915 down here behind these two caps. These caps are pretty small actually for 300 watts. Anyway, yeah, I think I'm measuring that at the front because of the fuses, those things there. So if I take the fuses out, or at least take one of them out, 5 amp time delay fuses. Anyway, I think if I take those out, possibly just one of them even, if I test these backwards again, yeah, we'll probably get something on. Now we're getting nothing. If I test the other ones, well, we get nothing there either. But there we go. It's something after the diodes that's doing that, and whether that's normal or not, I'm not sure. I think it's probably just those regulators. It's probably normal. So yeah, that's nothing weird. There don't seem to be anything weird with those diodes, and I didn't really think they would be. Those kind of things are more likely to fail shorted. Of course they can go leaky and weird, but probably not here. I just thought that was a strange thing, but I don't think it actually was. I think it was just those regulators downstream giving that reading, so that's a good way to trick yourself. I might also wonder if it could just be interference being picked up because the speaker leads are right next to the mains input when they're in the case, and the output from the transformer goes right past these leads that come from the preamp. So I don't know, maybe it's just interference being picked up because the cables are run next to each other, and maybe there's not really anything you can do about that. That's the thing, I don't know. It'd be great if you could take everything out of the case easily and just test it separately like that, but kind of hard to do. Anyway, I figured out if I put a box on the floor here in front of the thing, I can set it up this way and plug everything in and get access to it for voltage reading, so that was clever. Yeah, I got a strange thing I noticed. I was trying to figure out what voltages were supposed to be. I was trying to see if there was anything odd. I'm just going to change this actually for a second. Get off there. Okay. I just want to check the transformer actually first. So I'm going to put this in AC volts. Now I believe the transformer is a 24. Let's see if that's in shot. Can you see that all right? I think you can see that LCDs are kind of annoying to show up. Anyway, if I the transformer I believe is 24 volt. 2 windings, 24 volts each, so it's like 50 volts in a tap, whatever, you know. If I turn it on here, we get 28, 29 volts unloaded on one winding. That makes sense. If we go on the other side, see if that works. Do we get the same? 28, 29, no, yeah, we get the same. So the voltage coming out of the transformer is the same, right? 29, about 29 volts each winding. So it seems to be fine and normal. But what's interesting is if I look at the rectified voltage, whoops, coming out of it. So I put this back on DC, and if I connect up to, so let me just think, 29 volts rectified should be 29 times 1.414. Let me just calculate that because I can't think of that off the top of my head. But it should be over 30 volts, right? Let's see. So 29 volts AC times 1.414. Yeah, we get like 41. Right? 41 volts. So if we rectify it, 41 minus like a couple of volts for the diode drops on the rectifier. So maybe we got like 39 volts, 40, somewhere around 40 volts, I think. Rectified, no load. That's what we should have. Now if I just look at the schematic again, so I know which diode to look at. Downloads, where is it? Okay, so I can put my ground clip here on the heatsink clip on this chip, because that's connected to the chassis and that's connected to earth and ground. That'll make sense. And if I hook the other clip onto the anode of D7 or D5, which is the output for the positive rail. Well, actually, let's look at the negative first. D6, D8 anode. The anode of D6 or D8, we have the output of the rectifier for the negative rail. And currently there's negative 1 volts on there for some reason. But anyway, if we turn it on, we get negative 38.5 volts. Which makes sense, that's about what we calculated, right? 41 minus about 2 volts or something for the rectifier drop. And it goes away. Negative rail of that thing seems to be correct. We got minus 39 volts. 38.5. It seems to be about what you'd expect. But if I go around the other way, connect this to the positive rail, which is the cathode of D7 and D5, which is down here. Take that around the other side there. Okay. This is the positive rail, so you'd expect positive 38.5 volts basically, or around there. But notice when I switch it on, we only get 29. It's only barely more than the actual output voltage of the transformer unloaded, which is kind of weird. So we're missing almost like 10 volts on the positive rail. And if you look, interestingly, when I switch it back on, we get a thump sometimes if the caps haven't discharged. But if I turn it off, that voltage goes to 0 really fast. The voltage on the negative side dropped down slower, not very slow, it dropped, but it dropped slowly. This one, it basically dropped straight away. So possibly the main filter cap with the positive rail is bad. It could be high SR, low capacity, leaky, whatever, and then the rail can't actually get up to that that maximum voltage that it's supposed to. Or maybe it's gone open circuit, and I don't know, and maybe these chips have just got really good ripple rejection or something, and that's why we're not hearing it that badly. I don't think the voltage on that cap should drop like instantly. I think there's something funny is going on there. But yeah, so I think it's possible that filter cap, this one, I don't know which one it is, one of these two, maybe one of them's bad. I wouldn't be surprised. I mean, they are some cheap brand, Zundia or something, which I've never heard of. It just sounds like a generic Chinese thing. Doesn't sound like a good quality brand or anything. Possibly one of these has just gone open, or, well, probably not open, but could be bad. Yeah, anyway, so I think that could be it. I mean, the thing does run, it's odd. It runs normally otherwise. Like, you put an audio input into it. I haven't cranked it up like to really high volumes, but if I do it, like, I can put an audio input in, run it, it sounds pretty good. The audio doesn't really sound distorted or anything. So I kind of don't think that one of the amp chips is bad. Like, if one of the chips was bad, I kind of feel like it would distort, it would cause other problems. You'd get more buzz as the thing went up, maybe, I don't know. It seems a bit strange, so I don't know, maybe it is one of these capacitors that is bad. That would not surprise me. Again, given that they are cheap brand, and I don't know how old this thing is. I think this is a fairly old thing, and so, I can see the hot glue has kind of gone yellow, or whatever they've used, so maybe that's, heat related. So the caps could just be dead from overheat, heat over time, and just going bad. Alright, I just thought I'd do some in-circuit ESR tests, just to see if there was anything I could see, and this is kind of interesting. So if I took the fuses out, I don't think I needed to do that, but it gave me easier access to the PCB to get the connections, because obviously I can't probe the capacitors on the underside without taking the heat sinks off, and that's annoying. So if I probe, interestingly enough here, if I probe from the center pin input of the transformer, so that's ground basically, and to the output of the fuse, on that side I get a very low reading, 0.02, which honestly makes sense. For a good cap you'd probably see something like that. But if we go to the other side, we get 0.28. So we basically got a value that's 10 times that of the other side. And interestingly enough, this is the positive rail. So our negative rail, which seems to make sense, we're getting 0.03, 0.02, and here we got 0.2, 0.3 basically. So yeah, the ESR across the input to the filter caps on the positive rail is like 10 times that of the negative, which is quite interesting. I wonder if that is because of the capacitor. It does seem to look like that could be the issue. Quite possibly. Now I'm going to point to the correct one this time because I don't remember which one was which. Let me see. That's C15 is the positive rail, and that would be C15. Yeah, that one there. That one there on that end, that's C15, that's C16, so that's positive rail, that's negative rail. That one is at the top. So that one's going to see the most heat, because it's at the upper side where the heat's going to collect. I mean, they're pretty close to each other, but that one will be a bit hotter than that one. Anyway, interesting though. So I wonder, that does kind of point to the theory. Kind of looks a bit suspicious, doesn't it? I mean, the ESR across these should be the same if they're good, and to get an ESR that's 10 times higher across one and not the other is rather suspicious. So it does kind of fit. We got low voltage on the positive rail, and we've got a voltage that drops away really fast when we switch off the mains. As opposed to the negative rail, which drops away slower and also runs at 40 volts, which you'd expect. That's the voltage we're supposed to have. This one is running 30 volts, which is 10 volts lower than what it should be, and we're getting a buzzing noise out of the speakers even with no input. But it does seem to point to this cap being a problem, which would be good because these are much easier to replace and cheaper and easier to source than the ICs. There is like a 10 microfarad cap in parallel with it, but I think that's just down here. These are just decoupling, I think, for the 15 volt regulators, so I don't think that, if those were bad, that shouldn't affect the power amp anyway. It should have nothing to do with it. But yes, I'm very suspicious of this cap now. Very suspicious. It's not bulged at all, neither of them. They both have flat tops, perfectly flat. I don't see anything coming out the bottom. There's just a little bit of glue there, which has been put there to hold them in. But yeah, I'm very suspicious of that now. It seems like that's quite possibly the problem. So I think it's time to take this board, take this heatsink off this back plate, flip everything over, and take these caps out and check them, because I would not be surprised if one of these is bad. I'll be very surprised if one of them isn't bad, to be honest. This one. If it's something else, but it definitely looks suspicious. See, I actually should mark one. Mark the bad one. Let's just scratch an X in the top plastic layer there. I don't know. I can't really. Oh yeah, I can see that. That should work. All right. I took the back off there, and you can see, well, the back, the mounting plate, whatever, from the heatsink. So you just undo these 6 screws, which I've got up there, and I actually didn't get any heatsink on. Well, a little bit of compound on my fingers, but anyway, it looks like it's got a nicely decent amount of heatsink paste, so that's nice. Not that this is going to do much heatsinking compared to these, I guess, but anyway, yeah, so that's how you get access to that. Best to do it lying down. If you try to do it the other way, it wouldn't work, but yeah, turn that upside down, take the screws out from the back, pull it up. It seems to work really well. So now I've got access to those capacitors, which are right in the middle. Fortunately, I don't have to go under the heatsink or anything, so that's nice. So I should be able to desolder those, and we can have a look at them and see what's going on. This just keeps getting weirder, actually. I mean, not that it was that weird before, but now it's just getting bizarre. Here's the cap I just took out, right? This one here, this is the one that I suspect is bad. Where's the camera? Over here. Zunder. Never heard of it. Some random Chinese brand. There's the cross I put on the top. You can kind of see that. Yeah, HP, 105 degrees apparently. I don't know. Maybe I can find a data sheet for that. Anyway, to take it out I had to... I tried doing it with solder wick. But yeah, these are plated through holes, and it was very hard, and I don't have a desoldering tip. I might have a desoldering tip big enough for this, but whatever. I just did like the alternately heat the pads and rock them until I got it out, which was actually pretty easy. I should be able to clean the pads out with a desoldering pump and wick and everything to put something back in, but Here's something weird I just noticed. This is where it gets very odd. I don't know if you'll be able to hear this, but if I shake the cap, you can hear something rattling inside. What does that make you think of? It's as if they've got a smaller cap inside this one. I think these are fake. I think this cap is completely fake. I think if I cut this open, I'm going to find probably like a 4700 microfarad Rubicon in there that's been salvaged out of an old power supply or something from a scrap heap. That's the kind of thing that they do. It's weird. I don't know if you can really hear that. I mean, unless the thing is so dried up. But it feels like something with... You can hear it. I hope... Yeah, I think the microphone's picking this up. It rattles. There's something rattling inside there. I think it's a smaller cap. I think these are fake. I think these are completely fake. So, just because this top here isn't bulged, doesn't mean anything. The one inside is probably bulged. It's probably leaking everywhere, but that's why there's no leaking. I mean, this here is glue. This is just glue where they glued it down to the board, but I reckon this is a completely fake cap. And if this is fake, the other one's probably fake. So I'm going to pull both of them, and I'm going to open this one, because I don't think this is a real cap. I have never seen one of these in my life before. Not in real life. I've seen them on YouTube, other people with them. But yeah, this would be hilarious if that's what that is. Because I can't think, there's no other reason why a frickin' electrolytic would rattle like that. It's like there's something else stuck in there. It's either dried up completely to the point where the the internals have dried so much that they're just a completely shriveled solid bit of paper and they're rattling against the case, but nah, I reckon it's fake. I reckon it's a re-sleeved fake cap. Or a real re-sleeved cap to be fake. Anyway, I'm going to pull the other one. I'm going to see if it also rattles, and I'm also going to test them both on my capacitance meter and test them ESR out of circuit and just see what it's like. But yeah, I really think this could be a fake cap. How interesting. Anyway, on to the next one. So I've got a soldering iron here. I couldn't use my normal one on the bench because it wouldn't reach down here, but I've got this one here. It's a it's kind of interesting actually. I got it from JCar the other day. It's supposedly a 20/130 watt one, and you press this, hold this button down to get it on 130 watt. It's interesting. It says don't run it for more than 30 seconds on the max power, but it seems pretty powerful anyway. Either way, now I've got heatsink paste all over that. Anyway, I'm going to just take this other cap out now, and we can compare them, and then I'm going to open that and see what it's like inside, because I'm very, very suspicious of that. And now this is hilarious, because Behringer is supposed to be a decent brand, and I mean honestly everything else in there looks pretty good. You know, the design doesn't seem that bad, and the parts don't seem terrible, but this, if these main filter caps are fake, I mean, how many of these things are out there? Well, okay, let me not get ahead of myself. We don't know if it's fake, but it rattles in a really weird way, and I'm very suspicious of it. But anyway, let's pull this one out. Let's see if I can do it on camera, shall I? If I just heat that leg there, and then I pull it a bit, let it cool down, and then heat the other leg, push it the other way a bit, let it cool down, because if you don't let it cool down you'll just put it straight back in the hole and you won't get anywhere. There you go. I don't know if you heard that squeaking noise, that's it coming out of the hole. got it there. You got to use a bit of force with these things, but you got to make sure everything's heated, or you rip the through hole out, and you definitely don't want to do that. Okay, I've got everything heated. It's come out. It's just stuck on with the glue. I just got to pull it a bit more. There we go. That's got that out there. Looks fine. I mean, yeah, this one doesn't make a noise. I can this looks but yeah, nothing rattling around inside this one. So could this one be genuine and this one fake? I don't know. Weird. Still, I mean, they're exactly the same brand, exactly the same marking. Yeah, anyway. Very, very odd. I'll test those in a second. I'll just put my soldering iron away and everything. Clean this up a bit, ready to get the new parts installed, because I assume that's what I'll be doing. We'll be buying some proper caps and putting them in. I certainly won't be putting these back, because I want to find out if they're fake or not anyway, so I'll be pulling them apart regardless. So this thing will need new caps, no matter what. But yeah, I'll just clean up this the pads and everything. And I'll get it ready, but yeah, I won't bother showing that because that's not particularly interesting. It's just solder wick and a desoldering gun, which, I mean, a desoldering pump, which, you know, you've probably all seen about 1,000,000 times. Alright, we've got both the caps out, and I'm going to test the ESR out of circuit and see what that shows us. So, this is the, is that the rattly? Yeah, that's the rattly one. Only rattles on a certain angle. This is the one which is dodgy. What does it measure? It actually measures nothing. Huh! Well, colour me surprised. I guess I was measuring the ESR of the filter cap on the input of the 7815. Not this, because this is, well, yeah. Anyway, what about this one? 0.06. Well, yeah, we measured 0.02 before on the negative rail. So that would be in parallel with that other filter cap. So the resistance would be lower. Makes sense. But yeah, this one is measuring fairly normal, and this measures absolutely nothing. I don't know. I did heat this one for longer because I was trying to like suck it out with solder wick. Interestingly enough, I mean, I was trying to wick all the solder out of the hole so I could just pull it out instead of doing the rocking to and fro method, because I wasn't sure if that was going to work. But fortunately, these leads are nice and straight. They don't have those little kinks in the middle that hold it against the board really tight. So I was able to do that. I wonder, possibly, if there is another cap inside here and it's fake, maybe the excess heat desoldered that from inside and that's why it rattles now. But I don't know. Either way, I mean, this one basically measures open circuit. Again, if that was open circuit the whole time, I'm surprised the amplifier worked as well as it did, actually. It's kind of amazing. Yeah, that kind of credit to the LM3886, that it has like enough ability to get rid of that much ripple if the capacitor was literally gone. I'm quite surprised. But yeah, I mean, those chips are pretty known pretty well for being pretty good quality, so anyway, if that was the case, that's amazing. But yeah, I'm going to put these on the capacitance meter just for fun. I just want to see actually what the good one measures, because I'd be surprised if it measures 6800 microfarad. Okay, I've got my capacitance meter here. This can go up to 9,999 microfarads, so that'll be enough to test these if they are the 6800 that they claim to be. So let me see. Switch it to microfarads. No, that's picofarads. We want microfarads. 29. Turn that on. We get nothing, which makes sense. Alright, so let's test one of these. Let's test the good one first, I guess, or the good one. The not dead one. Right, let's see what we get. Yeah, 38. Oh no, sorry, I was just still counting up. Okay, 69. So it is what it says on the label. It does match up, so that's fine. Okay, I'll give it that. The value that it shows is what it says it is, so that's good. And what about this one? Again, I suspect it'll show absolutely nothing. Negative lead, positive lead. Yeah. Zilch. 0. Let's take the range down a bit. 10 microfarads? No. 0.01 microfarads. So we've got 55 nanofarads. Supposed to be 6800 microfarads. It's measuring 50 nanofarads. So yeah, it's gone. We already knew that, but there we go. That's what it actually reads. I wonder if it changes if I rattle it. Oh, goes up a little, goes down a little. 60 to 27. I can make it go between 50 and like 20 by just rattling it to and fro. Okay, yeah, there's definitely something funny going on inside there, isn't there? Very, very strange. Well, that proves what we already knew. So it looks like we've found the fault with this thing, or at least a fault. Yeah, this cap is totally open circuit, basically. Well, not totally open circuit, it's 68 nanofarads, maybe, if you hold it in the right angle. Anyway, it's certainly no good for what it's supposed to be. I'd say that's most likely the fault with this thing. I doubt there's anything else wrong with it, because like I said, when you play audio through it, it sounds fine. It's just that weird low-level background buzz, and yeah, I'd say it's that's dead, so that's most likely why. It makes perfect sense anyway. I have no idea how the thing was still able to run as well as it was, but yeah, this is toasted. But I guess there's only one thing left to do. Well, there's two things left to do. There's obviously replace these caps with new ones, because there's no way I'm trusting this other one even though it measures normally, and this one is dead. But the only other thing to do is to open this thing up. Probably open both of them actually, but I definitely want to open that one because I'm sure that's got to be fake. It's got to be fake. What else could it be? Why else would it rattle like that? That is very odd. Alright, it's time for the autopsy, or something of that nature. Let's see what we can find out about this capacitor here, which shakes and rattles and sounds more like a tambourine than a capacitor. I mean, or a castanet, or something like that. Yeah, sounds like one of those. I think that's what I'm thinking of. I mean, it's got spirit. I mean, it is an audio amplifier. It's supposed to play music on it, so it's misguided, but it's got the right idea. Anyway, let's see. What can we do? I'll see if I can use the side cutters here. So, first of all, I'll be interested to see what's under that plastic thing on top. Sorry for the weird camera angle, and I hope I don't go out of focus or out of shot or anything, but I don't know. We'll see. Let's take the label off. Anyway. Okay, so, yeah, that all looks normal. Sure, so that all looks what you'd expect underneath the label. Fairly standard, but what's under here? Let's get that glue out of the way. Now there, alright. I wonder if I can, how I can actually do this. Oh, there we go, cut through it. Let's see. I'm seeing something brown under there. Maybe I should get my ring light on so we can actually get some light on the scene. I don't know. Let me just give this a try. This might look better, it might look worse. Not sure. You can see a brown thing. Base plate sort of thing, makes sense. Let me give it a sniff. Does smell like capacitor. Actually, I'm looking. No, I'm seeing paper windings. I think. Yeah. No, I think this is legitimate actually. I think this cap might be real, or at least it's not a recanned something else. So apologies to Zunder for thinking that their caps were fake, but looks like I was wrong about that. But oh no, there we go. There. That's what's happened. I think the lead is broken off. It looks like. One of the leads has broken off, and that does look actually wet inside. But yeah, it's not. Well, it might have. Strange. I wonder if I measure that. Yeah, I can smell electrolyte. It's definitely a real capacitor there. So yeah, that's mildly disappointing. I thought I was going to find a hilarious fake. Never mind. Let's test the ESR directly on the inner terminal and see what that shows. Can I get that in shot there? Oops, hang on. Zero the leads out. So if I connect here and there. Oh yeah, we're getting something. I don't know. We are getting a reading there. But, I mean, it's not very... Oh, sorry, my hand's in the way. It's not consistent, it's going up and down. I mean, that makes sense. But yeah, that's... well, I guess there's no point opening the other one then. I guess. Just looks like it's just... Yeah, that terminal is just broken off internally. That's interesting. I mean, I suppose that's a failure mode. I wonder if that's... Was that just caused from vibrations from the speaker playing at a loud volume? I don't know. I don't think that would have come off with me desoldering it. It shouldn't have anyway. That doesn't make any sense. So that's just snapped basically. At some point in its existence, that you know, you can see there what it's supposed to look like. It's supposed to be a metal strip that goes up and folds over, but in that case it's, yeah, either bad manufacture or a lot of vibration has caused that to happen, I suppose. But there we go. That explains why it says it's open circuit. We didn't get the amusing fake that I thought we would, but we did get an answer as to why this thing doesn't work. It's quite obvious that the cap is in fact bad. I mean, yeah, there we go. I mean, I don't know why it's rattling like that. Is it just because it was only held on by one terminal, or was it actually dried out a bit and gotten smaller? I'm going to turn this light off. Yeah, I don't know. One or the other, or both, possibly. The seal seemed fine. There was nothing leaking out of it. You can still smell the electrolyte, so I don't know. But yeah, let's give it a test again. See if I can get a good connection on that tab there. maybe now that I've peeled it up. I mean, it's dancing around all over the place. I don't know why. It looks like it might be stable at like something around 2 ohms, 2 point something, but well, that was because I just touched the leads together. Yeah, I don't know. I could test it on the capacitance meter again and see what it shows with a direct connection. Might be worth giving a try. I mean, it would probably show something fairly sensible if I test it now. Let me just grab that again. There we go. I'll just bring this in again. Where's the power for that? Let's plug in some power. Oh yeah, I need the test clip. Ugh, I can smell this damn thing. It smells bad. Ugh, gonna need to stop filming pretty soon so I can stop smelling this gunk. Actually, I'm gonna just gonna hook up a separate test lead for this, just in case I get electrolyte on my good test clips. I don't want to, you know, get them corroded or something weird. I'm just going to connect this to a separate thing here. But yeah, let's turn that on. Let's put it back up to the max range. It should make sense. What's that? Which terminal's which? I don't think it really matters. That's positive is the round one, which is the one that broke off. Negative is the other one, which is the one that's still attached. But yeah, if we connect that to here, oh, we actually do get now 6800. So 69. Yeah, so this cap was actually still fine internally. It's just the lead broke off. Or maybe it was in the process of breaking off, and who knows, or it was high up. Yeah, it's possible it was kind of coming off when it was in the amp, and when I desoldered it I broke it off completely. It just completely failed with just the application of a bit of heat from the soldering iron, maybe. I don't know, hard to tell. I didn't try measuring the capacity in circuit, so I'll never know, but yeah, I mean, it tests good like that, funnily enough. So it was fine, it wasn't dried out, I don't think. It's just, yeah, just the lead broke off. So there you go. Electrolytic capacitors, they don't have to go high ESR. They can fail. They can fail with the leads breaking internally, which makes sense. But yeah, so that's it for this point. Obviously I'm going to have to order some new caps. This one is probably still good, but I mean, I don't know. Yeah, I don't really want to put this back in. I think I'll just get 2 brand new ones and yeah, just do both. Why not? I mean, this is probably old anyway. Who knows what the condition is? Who knows how much life it's got left? I don't know. I think it's better to just replace both and see what happens. Oh yeah, there we go. Internally broken off lead. And I mean, maybe, yeah, actually now I think about it, maybe it was already loose in the can. Maybe that was the original problem. Maybe it wasn't rolled. Well, I mean, maybe the thing was rolled too tight, or something. The can was slightly too. I mean, the capacitor roll was rolled too tightly for the can. It was loose in the can. The vibration from the speakers in the amp just over time just fatigued that metal and it broke off. or at least got cracked to the point where it was making a poor connection or something, and then it just eventually died. That's all I can think of, but that's probably why the amplifier has that buzzing noise. It's probably because that cap was faulty. I'll replace them, and then hopefully it'll work normally. That would be great. So yeah, not sure when that'll be. This might just be a part 1, and then I'll come back with a part 2 when I go to put these in. Put the new ones in. Well, not these ones, I'm not putting that back in. Obviously that would be crazy. But there we go. What fun. Interesting. Yeah. Well, either I will continue this video, or this will be the end of part 1. Possibly see you next time,